If you want to build a ship, don't drum up the men to gather wood, divide the work, and give orders. Instead, teach them to yearn for the vast and endless sea. So my biggest thing here is motivation is key to learning, and I think school is really good at how to do things, but not why. And I think that why is really important to you learning and actually enjoying what you're doing. So this quote gets at that. Another one of my favorite quotes, never let your schooling interfere with your education. This is Mark Twain. So, you know, you're actually really lucky to be in engineering because it's a rare field where your abilities speak louder than your grades. You may not know this yet because you're around professors and you're in school. But really, I mean, your ability to build things and create matters more than your grades. So don't worry about it. And you're also fortunate because microcontrollers enable you to build really crazy, awesome things. So this is probably the most useful class that you're going to take at Minnesota. And you know, it seems like a really tough class, but in reality, it's very enabling. It lets you do all kinds of really cool things. So you should be excited. And to get at why you should be excited. So supposedly this class is difficult. Microcontrollers are difficult, but compared to what? So if you think about building some of these circuits without microcontrollers, you realize how much easier microcontrollers actually make it. So I actually started my college education at a different school in Wisconsin, which didn't have any engineering. So no microcontroller class. Professors didn't really know about microcontrollers. But I had an intro to electronics class. And so this kind of shaped my view of electronics. And I thought you just use analog and logic chips, and that's all you get. And so as an example of this, I had a class where you learned about 555 timers. And there's this great little chip. It gives you, certain output of a certain time. You can make function generators and tone generators and stuff like that. And we had one lab where our professor told us, we came in, he said, today you're just going to build whatever you want with 555 timers. Anything you want at all. And so my imagination started going, and I heard someone making a tone generator, just a beep sound. And I thought, it would be really cool in movies like in Die Hard or whatever, you always see Bruce Willis trying to fuse this bomb, and there's like blinking red lights and like a display, and it's, the beeping is like speeding up towards the end, and it's totally theatrical. No one would ever do that, right? But it's something you always see in movies, and it's kind of a fun, exciting thing. So I figured I would build this and see what my professor thought. So I got a little video here. Let's see if I can. So this is my breadboard. This is in lab. So I got this little beeping circuit, and then it'll get to a certain point and it'll actually speed up. And then it should go to a solid tone. So that was it. A professor walked over, and I was all stoked about this. I just got it working. I spent way too much time doing this, and instead of being excited, my professor just kind of looked at me and just shook his head like, "What the hell is this? Like, why did you build this?" And later, that same professor, who was my academic advisor, told me that I'd either end up in jail or as CEO. So I guess this is what caused that. And so, I built this, and I started thinking. At the time, I was playing a lot of paintball, and I had played a video game called Counter-Strike, which some of you might know, where there's this really great gameplay where you have two teams, terrorists and counter-terrorists, and the gameplay is the terrorists are trying to get to this bomb site and start this timer on this bomb, and then the counter-terrorists have to defuse it to win. And so it makes this really great gameplay where you're both kind of attacking at the same time, and I thought it would lend itself really well to paintball, and I thought, hey, I could make this into a product and sell it, for paintball fields. And so based on what I knew, I said, okay, well, I guess what you do, you take your breadboard. You can't sell a breadboard, so you make a PCB. And this is without knowing anything about PCBs. So I jumped in. Here's my schematic for my breadboard. Real messy stuff. Some of my gates are like upside down, and this is probably one of my first schematics, so it looks like total crap now. But you can see there's some comparators that do the timing. There's 3 op amps that just give you those 3 phases of timing, like the beeping and the speed up sequence and the beep at the end, and some 555 timers. And I made it into a circuit board, and you'll see how utterly horrible this board looks. If you know anything about making boards, I actually auto-routed all of this. Matt will be proud of that. And so all I did, I just kept moving the parts around and hitting auto-route until it did everything. And there's some like right angle traces in there, and there's on the bottom right, I don't know, one trace is twice as thick as the other, so I don't know what I was doing there. But I thought, all right, I'm on my way. And so at the time, I figured the cheapest and quickest way to make this board is to etch it on my own. Just make a circuit board. You can buy copper-clad PCBs, and you can actually print out your circuit board on like photo paper and iron it on to the copper, and then you etch it in acid, and it tears away all the copper that's not underneath the traces. So I jumped in. I got some, I don't remember what chemical that is, but something that probably shouldn't be in a plastic cup like that. It worked, though. And I etched my own board. This is actually a 2-layer board, as you can see on this last screen here. Red is on the top, blue is on the bottom. And one funny side note, I was going through this presentation last night, just checking everything over, and I recognized something funny about my left hand in this picture. Sorry about that. Once I saw that, I couldn't take it out. It was too great. This is in the metal shop of my other school, actually. And what did I find out? This shit was hard. It didn't work. Just to begin with, I built my own board, so all those vias in a circuit board that connect the trace on the top to the trace on the bottom, when you order boards, they have this little via plating machine that does all these for you. Since I didn't have a via plating machine, I had to solder little bits of wire for all those vias. And it was extremely slow. You know, maybe there were 25 vias. So before I even started putting parts on, I had to solder 50 points. And then I found that everything was based off my breadboard, where I'd just been plugging parts in to see what worked. And all these parts have a tolerance. So, you know, usually 5%. And you can get precision parts, but I didn't know that at the time. And so I built this, and all of a sudden, all my timing is off. Like the tone, instead of being like a beep sound, was like burp. And I was like, that's horrible. How did that happen? The beeping wasn't the right time. And then to make matters worse, I was using this multimeter, this $5 multimeter. This is a word of caution to all of you that have $5 multimeters. A cheap multimeter has low resistance in voltage mode. So it might have 5 mega ohm between the 2 probes, which should be infinite in a perfect multimeter. And so what happened, I probably picked bad values for some of the parts. Like it probably had 1 mega ohm resistors in these RC timing circuits that set the tone frequency and the beeping and everything. And so, you know, you'd have the circuit and you'd measure it and it'd actually change what was happening in the circuit. So that's incredibly maddening. If you think about this, like you hook up your multimeter, you get everything working, you're kind of starting to understand what's going on, and then you move the multimeter and that part stops working. So it was totally, you know, I was almost pulling my hair out. I spent probably 50 hours trying to get to work, and I said, you know, forget it, I'm done. And this is hardware. You know, there's no breakpoints. You can't step through your code and kind of, you know, see what's going on. It's hardware. It's hard. And then a friend of mine mentioned, hey, it sounds like a perfect thing for a microcontroller. And I was like, well, I've heard of these, but I don't really know anything about them. You know, what's a microcontroller? And he says, well, you know, it's just a little chip you can program with your computer. You can put any code on it, and it'll execute your code. And they come in little, you know, small packages. And so I thought, hey, this would be perfect. And I just went off to Google and started typing in microcontroller, and I found PIC, which seems like the most common one. And I got started. I bought some chips, just randomly picked some parts that looked like people were using them, and got a programmer. And I started writing code in assembly. It seemed like most people were using assembly, so I chose assembly. Probably not the best choice, but hey, whatever, I'm making progress. And it blew my mind. It was so much easier than what I'd been doing before. You know, you write code, and the code executes the same way every time. There's no RC circuits, there's no multimeter interfering with it. You just write your code, and you run it, and it works. I was like totally blown away. This was amazing. And so I redesigned that last circuit, made a new circuit board, and came up with this. So this was my new Hollywood-style beep timer, and I even was able to add features. So I added a display. I have some buttons. You can set the time. There's even a diffuse button, like in the game. We have to hold it down for like 5 seconds to diffuse it, and I learned all kinds of stuff, and it actually worked. And then, look how simple the board is. There's maybe 7 parts that aren't passive. The chip on the bottom horizontally there is the microcontroller. It's a PIC 18, I think. Same thing that you guys will use. And then the chip on the top is just a resistor pack and some transistors. And I think you actually might learn this in lab, but those displays are interesting because I started with a 1-digit display and got that to work, and then I started thinking, okay, now I want 3 digits. So there were 8 inputs for the 1-digit. If I want 3, they're going to be 24. I started, went on DigiKey, started looking up these parts, and there's no 24-pin 3-digit 7-segment display. I'm like, what the hell? How do people do this? And it turns out you actually multiplex the lines. So each digit shares the same inputs. So what you're actually doing is, if you display 1, 2, 3, you're displaying 1, turning it off, then 2, turning it off, and then 3. And it's just really fast, so you don't notice the difference. So that was another thing that threw me off. But I believe you do a lab. You might do a lab, something like that. Okay, they do. So I actually have this here. I dug it up, and it still works. I guess I'll pass it around. You guys can check it out. So you can see you got your time here. You can even set your time. You start it by pressing both. Actually counts down. Speed up much better. Yeah. So I was super stoked I got this working. And then you can reset it. Yeah, there's the diffuse button. I'll just kind of hand this out, and you guys can check it out. This is the diffuse one if you want to stop it from running. So this was all before I got to Minnesota to take this class, and it was really important to me and my kind of enjoyment of this class because I came in here knowing that microcontrollers make your life easier, not harder, and I had been just slamming my head on the wall writing this assembly code that I knew nothing about, was just Googling examples and doing things that would make real programmers just cringe. Like, I had absolutely no idea what I was doing. I was overwriting vectors in the code, and so I'd come up with these maddening bugs where it works fine. I have like 50 lines of code, and I add a 51st line, and then it stops working. And I'm like, I was almost getting superstitious. I had no idea. I was way over my head. So when I got to this class and we started learning about microcontrollers, I kind of realized, I had a motivation to learn it, which I think is the most important thing. It'll keep you interested, keep you excited. And for me, it was really because of these projects that I'd done outside of class that kept me into this stuff. So I'm telling you guys that I really think it'll help you out if you find a project that inspires you. Doesn't matter what it is. Pick anything. Pick something that you think you couldn't do. Whatever excites you. Pick a project that you like. You think, man, if I could ever do that, it would be awesome. And then just bite off small pieces one at a time. And it'll keep you excited about what you're doing in microcontrollers. And also reach out to people. You're going to get stuck when you're doing things that you don't know already, and that's fine. People are out there who want to help you, and there's this blog, Hackaday, where people just post projects, electronic stuff like this. And what you'll find is that people are really excited about their own projects, and so they'll talk your ear off about what they're doing, and me included. So if you want to read someone's code or see how they did a similar problem, just ask them, be like, hey, your circuit's really cool. How did you do that? And they'll just go on for hours. And I think one of the most important ones is this last one. You're going to be doing the stuff that you don't know anything about, and you're going to do it the wrong way the first time. There's no problem with that. As long as you're doing it, that's the important thing. So don't worry about the kind of experts that read through your code or look at your circuit board you did the first time and nitpick, like, oh, this trace is at a right angle, or this is the worst assembly code I've ever read in my life. Just forget about them. You can listen to them on like your second time when you're actually getting a hang of it, when you're becoming the expert. And along that line, this is a project that I started. I saw something on Hackaday, that blog actually, about this motion sensing paintball turret. So it's this thing, really cool YouTube video where it would sense motion, and like someone would run by and the thing would shoot them with a paintball gun on its own. And so I thought, this is the coolest project I've ever seen. I could never do it, but maybe I'm just going to buy some servos and do something similar. Maybe I'll do a remote control one or something like that. So I got started with this, and like, look how shitty this looks, right? It's on a 2x4 that I cut out with the jigsaw or something on the bottom and some plastic. I don't know where I got that. Looks like total crap, but I got started. And that led to this. I got into a robotics competition where there's, it was like a robotic shooting gallery. So they're white circles on a black background, and it would actually go through and find each one with a camera and then shoot them down. And so it was perfect. It was really exciting. It took me, probably 9 months to get to the point when I could do this. I was, doing really stupid things in programming. I had only one programming class before this, and but I, managed it over a long period of time. And then this actually led to the final paintball sentry gun. So this thing looks pretty awesome, but it started with this little piece of crap right here. So this is all aluminum. You could shoot this with a paintball gun. It'll be fine. The camera's protected. And it'll track motion. It'll do teams. Like if you have a red and a blue team in paintball, it'll only shoot like the red team when they're running by. So this is probably the coolest project I'll ever work on in my life. Really fun stuff. And my point here is, start small. It doesn't matter if your prototype looks like shit. Like, just get started on something. And so another thing that I think is going to help you guys is the right equipment. So when I was going through this class, I had already bought a programmer because I was working on this stuff, and it helped me out a ton because you can do the labs ahead of time in your dorm room or whatever apartment. And you don't have to worry about fighting over the programmer in the lab, which I don't know if there's more. Maybe there's 2 in the lab or something like that. So this way, you can do, if you don't finish your lab on time, you just go home and do it, drink a beer and finish your lab. It's a lot better. Or coffee or whatever. Tea for you losers out there. And so I have, let's see, I got a bunch of programmers here. I got 65 programmers in this box. And then also, these things are really cool. This box is already open. This is a USB logic analyzer. Pretty cool looking thing, actually. So you can hook this up and actually read these logic signals coming out of your microcontroller. And this helps immensely because if you think about doing the stuff without it, you're basically operating blind. You have no idea what's going on. It's just like, you write your code, you plug it into your breadboard, and it doesn't work. And where does that get you? So this will really help you out. We use these all the time. You'll find almost every engineering company you walk into, you'll see one of these logic units. They have another 16-channel one if you ever run out of inputs. I think this one's 8. And so I have 65 of these I'm going to give away. And yeah, this will make your life a lot easier. I think it'll really help. If I see any of these on eBay for beer money or something, I'm going to be pissed. Just drink premium. It's basically free. And I also think you should make, you're going to be working on these projects, whatever you want to, and you should make your own PCBs. It makes your life easier. Breadboards, are good for some things, but bad at other things. And it just looks cooler. You can point to your project at the end like that timer and actually show it instead of bringing in your whole breadboard. And so there's this website here. I'll include this in a link. Maybe I'll try to get an email out to all the students or something like that.
Just send it to me. I will put it up on the web.
Okay, great. So this is a group buy on circuit boards, and I think they do it every week or twice a week now. Tons of people use it. It's incredibly cheap. You can get, 5 boards for like $10 or something like that. It's ridiculously cheap. I haven't used it, but a couple of these guys have, and it works pretty well. If you're willing to wait a little bit for your boards, it's great. And they actually take, I think university is using Eagle. They take Eagle design files, so you don't have to export any Gerbers, which can be confusing. You just send them your actual board file from the program. So it's super easy. And they'll show it on there. They have this nice little web script and everything, and it's really, really cool. And, just go out and invent something. I think you guys have a unique opportunity in that you're in a field that enables you to build and create things that can be distributed in mass to people, to improve their lives, to make them have more fun, to whatever. And there's another great opportunity right now, which is Kickstarter. So if any of you have an idea that you're really excited about and you want to turn into a company, you can fairly easily do that. And this has never existed before. This didn't exist, or it wasn't as popular when I was doing this stuff. I totally would have used it. I used it for one of my later products, but it's really at the moment now where there's tons of people on it, and projects are raising, over $500,000 and up to like, $12 million, $20 million. So it's a really great thing, and you guys can totally build this stuff. As an example, this is something that you could do with only your knowledge from this class. So I had this idea. I bought an iPod Touch while I was in school, and I promised myself that I would never install any games on it because I knew I'd be sitting in class and I'd get bored and I would just start playing Mario. And I stuck to that for a while until I had a really long flight, and I thought, screw it, I'm going to put Mario on here and save myself some time. So I was playing Mario, and I saw that without physical buttons on the phone, the experience is horrible. Like, I sucked at Mario. And this is a game I used to play when I was like 7, and I was great at it. And now I'm horrible. And so I was like, I thought to myself, there's got to be a way to add these physical buttons to the game to make it easier to play. And being an electrical engineer, the first thing I thought was the thing on the left. Let's make a circuit board. It'll adapt between a PlayStation controller and the iPhone. It'll be really simple to make. It can spin the boards really quick. You just plug in your controller, and you could set up your phone and just play using your PlayStation controller. So super easy. So I went out. I started building this. Actually, the interface to the PlayStation controller is one of these peripherals you're going to learn about. It's SPI. So it ended up being fairly easy to read the button presses and the analog sticks and everything. I found an app developer out there that was willing to support it, the guy that does all the Nintendo and Super Nintendo emulators for the jailbreak community. So I thought, all right, I'm going to nail this. There's like 200,000 people out there playing these games, and they're going to love this. And then I actually read this rule on Apple's website. There's actually, there used to be, maybe there still is, a section that says, it's like, section 34, game controllers. Apple will not allow any game controllers. And I'm like, shit. It's all done, basically. Like, I could only do the jailbreak community, which is big, but I thought not big enough to be worth it. So, I thought I was done. And then I thought of the idea on the right, which was developers are already taking space on the screen for these buttons for your thumbs. And so why not build a button that actually sits, attaches to the screen and gives you this tactile feedback without requiring any plug-in There's no way Apple can deny it because the phone thinks it's just a finger. And so I built a product that ended up as thummies here on the right. This was sold in Best Buy across the U.S. And it did okay. I licensed it to a company. There's a whole slew of lessons there. If any of you are, turning products, inventions into products, please give me a call or email or whatever, and I'll tell you all my, horror stories and lessons learned about this one. So I licensed it to a company that sold it to Best Buy. They handled the manufacturing, but they did things horribly on the packaging. Like there's a misspelled word. I think, yeah, if you see underneath thummies where it says the ultimate Mobley gaming control. So it's like, come on, guys, don't outsource your spelling to China. Like, okay, manufacturing, but you can write the text yourself. So, if you license a product to a company, you often lose. You can't control everything about it, and so things like this happen, and you can't really do anything. Anyway, this is something that all of you guys could do. There's plenty of other things that connect to the phone and are relatively simple microcontroller projects. And so that's basically my thing is go make something. It's going to make your life in this class better. It's going to make your career better. It's going to make you happier. Get excited about it. I've set aside time to help all of you out. That's my email address, my phone number. I'll send that out with the email or put on the page or whatever. Yeah. I'll try to put up the slide at this link. It's not up there right now, but I'll get to that. And yeah, like I said, I've set aside time to help. I'm doing this because I went through college with some complaints about how higher education is run and how there's kind of a lack of motivation as to why to learn this stuff, which I think is the most important. And so this is my experiment to see if I can improve it. And you guys are the guinea pigs. So I really hope you get excited about this, you get stoked, you build something. Please, email me if you need help. I'll be checking in. Maybe I'll come and, come back to Minnesota halfway through the semester or something like that. And I really have high hopes for you guys. I think this is going to be awesome. I want to see some of you become presidents, astronauts, billionaires. I want 10%. Really think it's going to be great. And that's it. So I'm pretty much done. You guys can come up here, grab some more coffee. You can check out some of these like prototype stuff that I worked on. And then each one of you can grab one of these logic analyzers and a programmer.